Welcome to the RIEEE webinar for April Fool's Day 2022. I'm happy to hand it off to SAEREC Director Steve Siegel, Professor of Biology and Director of the Southern Appalachian Environmental Research and Education Center, or SAEREC, and he has assembled a really great conversation for us here today. So I'll pass it his way, and thanks so much, Steve.
All right, thank you. I'm going to go ahead and start off by sharing a screen here so we can kind of get our feet under us. And let's see, slideshow in the beginning. There we go. All right, so screen's a little bit full there, perhaps. Maybe I'll take it out of that and leave it at this scale so I can see faces now. At any rate, our topic today is water quality and management here in the high country. Now, a lot of people can define the high country in a lot of different ways. Some people look at that as Western North Carolina in general. Up in this area, it's often a 7-county area up here in the corner of the state. But either way you look at it, the issues are going to be the same. So we're happy to have people here today, and hopefully we can get a good discussion going. So I like to frame a lot of the issues that I look at in the context of ecosystem services. And of course, as I think most all of you know, ecosystem services are natural ecosystem outputs or conditions or processes that either directly or indirectly can benefit humans and enhance social welfare. I tend to include human-dominated systems in that because we certainly can't live without agro-ecosystems and that sort of thing. But either way you cut it, this diagram on the right is a little bit biocentric in the sense that it features biodiversity, but there's some really important points in here. Ecosystem services come in a whole variety of flavors, but any way you look at it, in any category of ecosystem services you look at, water is prominent. Freshwater is a provisioning service. Recreation and aesthetic values certainly includes our water resources. Water cycling within ecosystems, and then finally water purification. And it's in the nature of ecosystem services, they influence human well-being. But humans also, especially as we thrive, tend to influence the global change. Whether we're talking about climate, influences on biogeochemical cycles, land use, or even exotic species introductions. Okay, all of these feed back either directly to ecosystem functions and ecosystem services, or filter through things like biodiversity, which is one of our topics today. The other thing to remember about ecosystem services is that supporting ecosystem services are really the key for the production of the provisioning, cultural, and regulating services. They're the foundation. So we need to be, when we think about water resources and water resource problems, we need to be thinking ultimately about fundamental, well-functioning, high-functioning ecosystems. So that's kind of a lens that I look at things through. The other point that we need to keep in mind here is that water-related ecosystem services are not just local. Any aspects of water quantity and quality services that we have in Western North Carolina in particular radiate outward because we're at the headwaters of multiple large watersheds. As you can see in this little map over here at the left, up here is the traditional high country, but all of Western North Carolina is the headwaters for some really significant and larger watersheds. For an example, we can look here at the Catawba River watershed in the middle. This is in blue here. You can see it originates in the headwaters along not just the traditional high country, but other parts of Western North Carolina, and then flows eastward down through the Piedmont and so on. And if you look at a map of land cover, I always like to wonder, you know, in terms of ecosystem services, what we gain and produce in terms of ecosystem services here in the high country, which is mostly forested, that influences welfare and well-being of people further down the watershed. And obviously then looking at this as a local problem, also simply a local problem would belie the fact that all of our local resources are impacted at regional and global scales because of changes in climate and various other issues. So on the right here, you can see another way of looking at the high country as part of a larger region. And this is related to some work that I'm currently doing with an RIEEE concert grant, where we're focused on indicators of water quality at regional scales and being able to try and estimate the impact of land use change potentially on water quality and water availability. All right, for today, we have a little agenda here, a small agenda. We have about 4 questions that we should be revolving around. Starting off with a very important one, and that is, what are our region's most pressing water quality, water quantity, aquatic biodiversity, and management problems? And in terms of just delimiting those and listing what they are, we really need to understand, and I think everybody understands this, that we need to know the proximate and ultimate drivers of those problems. If we're going to work on any type of aquatic management problems, we need to understand what basic science and management expertise we need to utilize, or we need to develop or leverage to address those problems, especially if we're going to look at them in long-term, sustainable, and resilient ways. As I just mentioned, the region is experiencing local change and is influenced by global change. We need to keep our eyes on what new threats are on the horizon for water resources here in Western North Carolina, and really begin to wonder seriously about how we can be proactive in avoiding those threats, or at the very least, creating resilient systems that will help ameliorate those threats and maintain ecosystem services. And last, and this is part of what we're doing here today, what partnerships do we need to emphasize or develop in order to be able to address both current and future water quantity and quality threats? So with those ideas in mind, let's move on to our agenda. I've just given you a bit of an introduction to how I utilize ecosystem services as a lens to look at environmental problems. And I think we can utilize that then as we go through this process. We have 3 speakers lined up. There'll be short presentations because we want to hold a lot of time open for discussion. The first speaker is going to be Jeff Colby. He's in the professor in the Department of Geography and Planning here at Appalachian State. He'll be talking, I think, on some of his work from the upper South Fork of the New River. And Mike Gangloff, who is from the Department of Biology, is a stream ecologist, generally an aquatic ecologist, works on a lot of different systems, but his specialty is in conservation biology. And he'll be talking some about biodiversity. And as we obviously just saw, biodiversity is central to production of ecosystem services. And third, but obviously not last, we have Damon Hearne to bring us a perspective from a state agency. He's with the North Carolina Department of Natural and Cultural Resources. He's the Western representative for the North Carolina Land and Water Fund. Following those, then we will open it up for broad-ranging discussion, and I look forward to that. So I will stop my share here and turn it over to Jeff.
All righty. Everybody see that okay?
Yes.
All right. Just a quick introduction to the Aqua research group. I'm Jeff Colby from the Department of Geography and Planning, Shay Trubides from the Department of Biology, and Derek Martins also from the Department of Geography and Planning. And we've had about 30 graduate students work with Aqua over the years. And 3 of them have won outstanding thesis awards, and they're doing pretty well in terms of being gainfully employed in their background fields in their education and working with Aqua. And a little introduction to one of the areas that we work in quite a bit. The spatial domain of our study area is really the Southern Appalachians and headwater streams in the Southern Appalachians. But we've collected quite a bit of data in the Upper South Fork of the New River. Starting late 2010, we've been collecting data for about 8 different subbasins. We have over 1.5 million records of water quality, specific connectivity, temp, depth, pH, DO. We have a high resolution geospatial database that's based on a 1 meter DEM derived from Geiger LiDAR data, which is effectively the best elevation data that you can get publicly. We also have 1 meter land cover layers, and we developed discharge grading curves for several of our subbasins.
In progress.
Some of the, just a few of the current research topics we're working on. I had a grad student develop a micro hydro application using funding from the Energy Center, so that if a citizen calls the Energy Center and says, you know, is my property a good candidate for developing micro hydropower? We've got a remote application that's been developed so they can sit in their offices at the Energy Center and do at least an initial assessment of whether there's good potential for developing hydropower on that person's property. We've had a couple of dams removed in this area in the High Country, Payne Branch and Ward Mill and O'Shea. And Derek has done a lot of work doing research on the impacts of those dam removals in terms of sedimentation, effects on the benthic environment. And last summer, I had a student do land cover change analysis in the Upper South Fork, the New River Watershed. And he classified some 6-inch aerial photography from 2010, 2014, and 2018 for impervious and forested areas. And I was going to talk a little bit about that because that seems to pertain to our discussion today pretty well. To do that classification is a 2-step process to use some software called Feature Analyst in the GIS. We did an automated classification of impervious surfaces in the watershed. Then he has to go back through, drapes a fishnet across the watershed, and goes in and actually manually edits that classification. And you can see the results of one of those manual edits here. We moved the road of the impervious layer over on top of where that road actually really did exist. So he did a pretty nice job with this. And here's some of the results that he got, looking at a change in impervious surfaces from 2010 to 2018 in the watershed. And you can see we've got a continual linear increase in increases in impervious area and percentage of the watershed that's covered by impervious areas from 2010 to 2018. And just as a general assessment, the EPA says that a subbasin or stream is impacted if you have 11% up to about 25% of that area is covered by impervious surfaces. And to make these values a little bit more intuitive, we converted them into football fields. So between 2010 and 2014, we had about 28 football fields of impervious surfaces be created in the watershed, and from 2014 to 2018, we had an additional about 33 football fields of impervious surfaces created. So that's about 60 football fields of impervious surface that were created in the watershed between 2010 and 2018. And knowing that, I think is important, but also what's important is where those increases are occurring. And you can see here that Boone Creek and this State Farm area had pretty significant increases in impervious surface area in acres. Middle Fork also was pretty high, but that's also one of our largest subbasins. And so then how does this affect water quality? How's it related to water quality? Well, here's a map that was put together for a master's thesis. And this is mean specific conductivity from 2010 to 2015. And you can see in some of the most impacted areas in Boone, for example, we still have increases in impervious surfaces over that time period from 2010 to 2018 and high levels of mean specific conductivity. And we generally have three different categories of water quality in these subbasins. Winkler Creek, Flannery Fork, and Goshen Creek tend to be our reference streams, are in really pretty good shape. East Fork and Middle Fork are in the middle, and the most impacted is Boone Creek and Hodges Creek. And the last slide I'm going to show here is the percent of impervious surfaces in each of these different subbasins. So you can see that Boone Creek is really pretty high. The area here, at State Farm, that drains the outlet of the watershed. The outlet is at the covered bridge on the Greenway Trail. And ASU campus is up here in Boone Creek subbasin, and Blowing Rock is in Middle Fork subbasin. So you can see in Winkler Creek, Flannery Fork, and Goshen Creek, we've got lower percentages of impervious surfaces and higher water quality. Middle Fork and East Fork are in the middle. And then Boone Creek and Hodges have got quite a high percentage of impervious surfaces. So that's my intro. And I'll turn it over to the next speaker.
That would be Mike.
Hello. Yeah, so let me just go ahead, share my screen. Okay. I've been doing this for a while, but so it is an adventure with Zoom. Okay, so yeah, so my name is Mike Gangloff, and I am a conservation biologist, an aquatic conservation biologist here in the Department of Biology. And I'm just going to give you a little bit of an overview of the work that I've been doing in the high country of North Carolina, and really the things that we've been focusing on are the factors that drive changes in biodiversity. And some of those are, typically negative things, change, degraded water quality, increases in impervious land use. But, we're also seeing in some cases changes that may be improving habitat quality in some of these streams. Brief background about the kind of work that I do. So the kind of three goals of conservation biology are to document biodiversity, understand threats to biodiversity, and mitigate those threats, or come up with solutions to mitigate those threats. And so we kind of work in all three areas. And my classical, or my background is in primarily threat assessment, and as well as taxonomy and biodiversity discovery. And those are, again, certainly the things that I've got the most experience working in. But as research programs evolve, and also my thinking about how to deal with some of these threats evolve, we started to work more on projects that are attempting to understand ways to mitigate threats. And so I've been involved, for example, in some local dam removal projects, as well as in efforts to come up with ways to quantify imperilment levels and at-risk species. And we work in my lab on a pretty wide range of organisms, fishes, salamanders to some extent. Mussels are kind of my specialty, but we've also got projects going on with these really attractive. This is a Waccamaw crayfish here that's found not in the mountains, but down east in North Carolina. Oops. And dragonflies are a recent addition to our research focus. So I was always the kid with the Peterson Field Guide, and I spent my youth on Long Island, a biodiversity desert, dreaming about moving to a place like the Southern Appalachian Mountains, where you have just this incredible biodiversity hotspot, and some stats up there for freshwater species diversity. You know, it's a tremendous proportion of North America's freshwater species are found in this region. Many of them are endemic to small regions, or you know, are found only in headwater streams, and you know, that's in part due to biogeographical processes and vicariant speciation and things like that, but also increasingly our headwaters are becoming a critical refuge for biodiversity as development and human populations increase, and especially in places like the Piedmont region of the Southeast. You know, that has pushed a lot of species into more upland environments. Again, my background is in working with freshwater mussels, and I spent 9 years in Alabama, which is kind of the mussel capital of the universe, learning about freshwater mussels. And then I moved to a place with no mussels. It's you know, very briefly, it's just challenging environment for shell growth. You have very low calcium concentrations. The water is cold. It makes it very challenging to grow a shell. And so when I arrived here, I was told, well, there's not a lot of mussels for you to work on. And that is definitely the case. If you look at the bottom of the slide, the New River has or had 4 species of freshwater mussels, only 2 of which are still present in North Carolina reaches of the river. The Watauga River is 1 species, is now extirpated, and the picture of it right there, the green floater, it's still hanging on in the new. And then the Nolichucky River, you know, for super high species diversity for a blue ridge stream, is a total of 3 species. So, you know, again, pretty low diversity. So I had to find something else to work on, and probably the best analog in a vertebrate to freshwater mussel in terms of life history and ecological sensitivity is the Hellbender. So this is the most charismatic organism I've ever worked on, and they are truly a amazing animal, and their populations are not doing very well across, you know, most of North America. This is a prime example of a species that is, you know, that really makes use of these headwater streams as a refuge from habitat and water quality degradation. And we're, you know, North Carolina is very proud of the fact that we have some of the best remaining Hellbender populations in the world, really. And so it was, Hellbenders are a big part of the Watauga River ecosystem, and a couple of years ago it started working with Watauga Riverkeeper, hey Andy, and to try to get a sense of what the implications would be of removing this structure. This is Ward's Mill Dam down just downstream of Valley Crucis, and that dam was removed last year. And we here's a picture someone shot with a nice drone picture of the dam being removed, and we wanted to know how is this removal going to affect the biota of the Watauga River. And so we've been monitoring fish and Hellbender populations and trying to find mussels to no avail. And we've come up with a kind of a new method for finding Hellbenders, a rather not very disruptive method. So we started doing nighttime surveys, and some crazy pictures of nighttime surveys for Hellbenders. A pretty interesting departure from our normal daytime work, but we're, you know, basically counting them and leaving them in place. And, you know, if you're lucky, you see you get a nice picture of the animal's head. Sometimes you don't even see this much of them, but they're usually active at the surface of their crevices during the nighttime hours, and a little bit easier to detect. We get about the same numbers during the night as we do from turning over rocks in the day. So obviously a less stressful mechanism for them. And so as part of what we've been doing in this Watauga River project is looking at substrate concentration or substrate composition in the Watauga River. And what you're looking at here are the proportions of fine sediments in our substrate counts, or Woolman pebble count is a kind of standard method for quantifying substrate size. This red bar is the dam, and sites move from upstream number 1 to downstream site 11, left to right on your screen, and the bars represent pre and post removal data for these sites, following the removal of the dam. This red bar is where the dam used to be. And what I just want to point out with this slide, I know it's a little busy, but what we see in the Watauga River is that most of the sites with hellbenders, in fact, all the sites with hellbenders are clustered in the upper Watauga River. And so these 4 sites here are 4 of our monitoring sites with hellbenders. And you notice that the fine substrate composition levels here are much lower than they are further downstream. So this is Rominger Road. This is the former impounded zone. This is the tail race of Ward Dam. And so what we're encouraged by is that following the removal of this dam, we're seeing a coarsening of substrate composition here. Of course, in the impoundment, you would expect that, but also interestingly, seeing that in the tail race. And again, I'm not sure if how to explain that at this point, because we still do have a lot of bed load moving through the system, but it is nonetheless encouraging, and we're hopeful that some of these habitats, especially in the impoundment, are going to be turn out to be good hellbender habitats in the future. And I really like this slide because it gives you a sense of what good hellbender habitat looks like. And the animal is underneath a large boulder, but there's also very little fine sediment underneath that boulder. And I think that's really a critical piece of the puzzle for hellbenders and a lot of other sensitive aquatic species in this region. And so trying to come up with ways to mitigate fine sediment inputs is along with protecting water quality, a really critical part of protecting biodiversity in this region. And mountain streams are coarse substrate habitat. So we're kind of keeping on with that work. We'll be doing another round of monitoring this year. And this is just a list of some of the exciting things that we have going on in the lab that involve work in headwater streams in the Southern Appalachians, continuing to do mussel work where we can, as well as working on both the Watauga River and Middle Fork dam removals. And I could talk for hours about these projects, but I won't. Guess also want to thank a lot of the agencies that we've worked with over the years. And one of the most gratifying things that I can point to in my career at Appalachian State is that a lot of my graduate students and undergraduates have gone on to work for these groups and are now collaborating with me on new projects and funding new graduate students. So that's been super gratifying. And I know we got a little bit of an April Fool's joke from Mother Nature this morning here, and maybe a little bit of snow even in places. So I wanted to leave you with one of my favorite sites from spring. This is a chub nest, a river chub nest, and some spawning minnows, Tennessee shiners and moor paint shiners and stone rollers on a chub nest in the South Bear River. This is I think rivals anything you're going to see on a coral reef. maybe not coral reef, but it's pretty spectacular. So, you know, as the water starts to warm up a little bit, be on the lookout for these awesome sites of spring in our mountain streams. That's what I have.
All right, thanks, Mike. Damon?
Hey, get going here on sharing the screen. All right, you can all see that?
Yes.
All right. So Damon Hearne, Western Field Representative for North Carolina Land and Water Fund. I'm going to talk a little bit about conservation, land acquisition, stream restoration funding in the Highlands. Get things to advance here. There we go. So just real quick, a little bit about who I'm with, what we do. North Carolina Land and Water Fund is part of, as a state agency, Division of Land and Water Stewardship within Department of Natural and Cultural Resources. Those are the folks that are doing stewardship of lands, not enforcement. We're not part of DEQ. We do grants to agencies, local governments, municipalities, and nonprofits in the areas of land acquisition, stream restoration, wetland restoration, innovative stormwater, and planning for that stuff. We used to be called the Clean Water Management Trust Fund. If you haven't worked with us in a couple of years, you might know our history as the Clean Water Management Trust Fund. I think 2 years ago, we did a rebranding and renaming North Carolina Land and Water Fund, but we did not change our mission at that time. We're still doing the same stuff we've been doing since mid-90s, late 90s. So in the Highlands, I did some real quick stats this morning, just pulled up a map of the region. Somewhere around 251 funded projects since 1996, over $84 million in funding in those 7 counties, if I got the 7 right, which adds up to more than 30,000 acres of protected lands. And we haven't tracked it as well, but I'd love to do a more in-depth dive on our stats. It's somewhere north of 500 miles of protected stream buffer. A given stream on a property would have buffer on both sides. So, but we've always tracked linear feet of buffer, and that's one of the numbers. And I just put together a very long, very small font list of all the partners we've worked with there. Not meant for you to be reading necessarily, but to see how many different organizations we've worked with. A number of folks on this call or on the seminar I saw have current past grants with us, have implemented projects on the ground, and happy to hear thoughts or questions or input from them when I'm done. But the map here shows land acquisition projects in green, stream restoration in light blue, planning grants in purple, I think, and then a couple of innovative stormwater projects hidden in there. I'll try to keep it short and sweet, and I thought we'd go with some pictures of relatively current projects. You asked us to talk about what we think some of the key issues are on the topic from today. And I've kind of listed them out as they relate to 3 projects that I'll put up here. The first one is maybe one of the closer projects to where some of you all are sitting. South Fork New River, the Ted Mackerel Soccer Complex site had stream restoration work done, wrapped up, I think, probably a couple of years ago now. And some of the key issues there were stream bank and buffer disturbance, really lack of buffer and deep root integrity of vegetation, channelization, non-native vegetation that resulted in failing stream banks and high sediment loads, which of course we've hearing a lot about sediment in other discussions just before me. Picture here are, I tried to kind of line up before and after, top and bottom. So the left column is more or less the same curve, leaf on, leaf off, but before and after restoration there, you can see the laid back banks, more natural channel. You can see some actual moving whitewater there. On the right, you can see areas during construction being built, moving, laying back the bank and create an inner berm, and then after some great vegetation growth there. And the pictures there, the after pictures, there is some fantastic growth, but still waiting for vegetation to really grow up and lock in that soil on the banks on this project. Coincidentally, here's some pictures of or not coincidentally, I don't know. Middle Fork New Paynes Branch dam removal that we helped fund. Again, left and right columns, somewhat sort of more before and after of the same areas. Of course, any dam removal, you're going to get really significant changes in how they look before and after. But key issues here, you know, the impoundment creating aquatic organism passage barriers and significant sediment hazard for release if in the event of failure. So a lot of dams are just like you saw in the data of on the with the tail race being really low sediment right below the dam. Dams are holding that sediment back and keeping areas just downstream perhaps free of sediment or even unnaturally low in sediment. But especially when you get older dams with risk of failure, the catastrophic failure risk is incredibly high. And so this was an exciting project to see on the ground. The after pictures there are just after construction, really no vegetation having come up yet. And just to kind of point out the kind of work that we do, we're really interested in natural channel design and, you know, a vegetated buffer that's as close to a native condition, a natural condition as we can do. So when we fund projects that have hardened banks or more non-natural conditions, it's always as an exception or because of a given spot that's necessary. We're always trying to focus on natural channel design if we can. And the last one, bouncing back to right adjacent to that mackerel complex, but I put it in here because it is a wetland restoration project, not a stream restoration project. We do upland restoration or restoration of wetlands or even of erosion conditions that are contributing to water quality issues that might be originating in the uplands. And again, here in the left, you can see the previous condition of a field that was actually fairly wet, but certainly not looking like a great wetland. You can see the lawnmower tracks there and the generally drained previous ag field condition, and then wetland here on the right. I didn't have as good of a before and after, so I threw in some fun pictures of big excavators and the machines that make this stuff happen. But again here, drainage of wetlands, non-native species, lack of buffer, mowing, I'm sure relics of agricultural management, channelization, and that type of thing. And I actually haven't seen this project in probably a year's worth of growth, so I'm excited to go back and see the vegetation growing there. The vegetation, I think, if I was going to focus in on one thing, it's very easy to focus in on, very kind of a functional thing you can see. It's that stream vegetation, and I'm using this same picture as a background. This is Naked Creek in Jefferson, a project that we helped fund with partner work. And the reason I like this picture so much of a stream is because you cannot see the stream. And I think we are very used to seeing streams in agricultural settings, in a lot of settings, especially those moderate sized streams that you might be able to jump across or get your feet wet once, but not big rivers. We're used to seeing them. We're used to seeing that flowing water. And reality is the best thing for that stream is for us not to see it in most places, to have the vegetation jumping up, to have the deep roots down. And to me, and this has only got a year and a half of growth, but it was pretty amazing, quick growth. And the applicant did a lot of work to maintain vegetation and to transplant existing vegetation back in. And that is the biggest success that I see when I go out and look at our projects once they're in the ground, is those plants growing up, the bare rootstock growing, the live stakes growing, and I have to actually get in there into the brush to see the stream or use the trail or the bench and say, gee, I need to find the right place to fly fish here because it's not all great for casting. It's got vegetation around it. And there are plenty of bigger streams and rivers that we can see even when there's good stream bank vegetation. But I think even for folks that are in this day in and day out, we kind of forget when we're always looking at degraded streams or freshly restored ones, how much that vegetation should really be protecting the stream, both from sediment and in the view. So that's kind of my short and sweet version. I love I love our projects up in the high country. I love working up there. There's some really great, that long list of partners. There's a lot of applicants who have done repeated projects and done planning work to go out and find the best places to do the restoration, where they can move the needle, where the sediment issues are the worst, where the stream bank failures are the worst. And I'm also really interested in, and although we don't fund as much work on it, is understanding the land use change and what the inputs are that are causing the issues to begin with. So I appreciate you all asking me to join you, and excited to have conversation after this.
All right. Damon, that you were in it, where you ended up there was someplace that I wanted to go, and that is the idea of implementing restoration. Always a good thing, but how do you go about optimizing where you put it? Where do you invest the money to get the most bang for your buck in terms of restoration efforts? And obviously you got to think in terms of what are the outputs that you want to get. So what's the process?
Well, I'll just take a short whack at it, but I'm sure other people have other thoughts. One thing that we look for are places that are not downstream of issues that are going to bury the restoration or cause it to not be successful. So places that can stand and maintain without direct inputs. So example, huge sediment issues right above a stream that you're putting lots of rock and wood in the stream, it's going to end up being buried. There's a human aspect to it also, which is, where is it going to make a difference in the community? Where can you get an anchor for conservation and then lead out from there to do adjacent projects? I've seen a lot of projects where it may or may not have been the worst spot in the valley or the very top one, but it was the right neighbor to get 5 other neighbors interested and involved and lead out from there. We've paid for a lot of planning efforts that do beehive stream bank hazard assessment. Where are the worst areas, and then combining those with the opportune areas, the low hanging fruit. But that's a really good question, and we've struggled with that over the years to know how to put funds on the ground that are the most effective. And we rely on partnerships with our applicants who know the landowners and the landscape to figure that out. Some other folks on the phone may have ideas, or on the seminar may have ideas about that as well.
So we have, I see a lot of faces and names on here that I recognize, but they're people that I don't really know. I think you're from state agencies and stuff. You have a similar perspective to Damon, or do you have, what's your point of view on how we need to be managing these types of resources? Silence. All right, let me ask you this then, a more specific question. What about ex-urban development? We know we have issues, localized issues and associated with farming and urban areas and so on and so forth. Is ex-urban development a serious problem in your mind? I.e., non-residential, large plots of land, but scattered around to areas that would normally be forest. Do you see that, Andy?
Yeah, we're seeing it more and more. Certainly when the economy recovers and, building starts to take off. We were in a lull here for a while in the high country that I really enjoyed. Now it's heating back up. So anytime we see, I think Jeff's graph was very helpful, but the rise in impervious surface, I think we see a correlation in water quality impairments, runoff, steep slope development impacts to water quality. So it's something we monitor pretty closely. Land use change as well. When a family farm gets broken up into condos or houses, sadly, some of the first things we see when someone relocates to the high country is they want to cut down all the the brush and the trees and stuff so they can get a view of their stream, and then their bank fails and the fish leave or it silts in, and then they call us to complain.
One of the things that we've been tracking for 10 years now is how, and trying to understand what's going on is, we're seeing, if you go back and look at the EPA water quality data sets that are available on the web, we're seeing major changes in conductivity and pH concentrations across Western and North Carolina streams. And it's not just, streams in urbanized areas around Boone. We're seeing those same kind of changes in the, in the North Fork of the New River, in the main stem New, and places like the Little Tennessee River. We're seeing, in the South Fork of the New in particular, further downstream, the conductivity is effectively doubled in the last 20 years. And it was very rare at 421 in Perkinsville to see conductivities above 100 microsiemens prior to 1995. And now you never see conductivity below 100. And so there's this phenomena known as stream salinization syndrome that seems to be creeping in to a lot of Western North Carolina watersheds. And the only thing I can think of that would be driving that is exurban development. But
Interesting.
it's a widespread problem, and I've got a graduate student who's working on that right now, kind of trying to tie the biological and the water quality questions together, because in these same places we're seeing losses of hellbenders, the collapse of mussel populations. Little Tennessee River in particular is kind of a mess now, and that's really heartbreaking.
Are there any, do you guys see any other, say, chronic issues like that? This is one of the biggest management issues that I see in all types of natural resources, is chronic effects that go under the radar and then reach a critical threshold. And this is exactly that. And this is the way I look at exurban development. It's going to go on, and then sooner or later, though, because it's going to become problematic and perhaps show up, as Mike's saying, in stream water quality. We don't have much in the way of atmospheric deposition here. I don't think we have much of a problem with that. But I
No,
could be wrong.
from talking to Howie, it sounds like that is not as big of a problem as it was, pre 90s when we were getting a lot of deposition from the Ohio Valley.
Yeah. Yeah, that's something that's declined all over most of the country, I think.
Well, not in Iowa, but
Not in Iowa. Well,
yeah.
you do have localized effects. I mean, like nitrogen deposition down in southeastern North Carolina is still extremely high, but it's from a local source.
Yeah.
Anything else.
Yeah, I think that's what's going on in Iowa. USGS has a really cool graphic. You can go from 1985 to 2018 and look at the changes in atmospheric nitrogen deposition. Just looking at that the other day with my class.
George, do you have a perspective from someone who has to deal with sea sites with types of issues on a more localized, and as far as the high country goes, a more urban area?
Yeah, I was trying to think of how to respond. As you know, my more limited scope is very recent change in my profession. I was the executive director for New River Conservancy, so I saw an entire watershed that was really large, over 3 states and 21 counties. It was a different perspective now, being the sustainability manager for town of Boone and only working on a 6 square mile geographic region. You know, I think your question earlier about priorities and things of that nature, I think you almost have to be like, all right, here's the theoretical priorities, you know, headwater streams, other places where, you know, it makes total sense. And I know that Damon would love to be able to prioritize things in that nature, but there are the practical applications in the world, right? You can't force a landowner to do anything. So you have to find willing landowners who are willing to permanently restrict the use of their riparian buffer, because the Land and Water Fund will not work on and do a stream channel restoration or riparian buffer restoration on property that's not permanently protected. So, you know, there's this melding of the theoretical perfect solution and what is practically possible. And I think when you get into, you know, a more urbanized area like Boone, I don't even like calling it urban because we're a tiny town, but, you know, it's or a concrete jungle for sure. And trying to inspire landowners to allow us to work on properties. I mean, you know, again, the Land and Water Fund would require a 50-foot buffer from top of bank. That's could be half a property in the town of Boone, you know? I mean, that's almost not practical in some places. So we have to seek to do what, you know, I'm always of the attitude, I obviously am not in academia, and I don't strive for perfection in anything that I do. I strive for better. And so that's really all I feel like we, you know, or at least in my profession and what I've done, that's what I find is possible. These dam removals are spectacular. I mean, I had a very small role in the Middle Fork Dam removal. I connected the parties and watched it happen with great joy. It was an absolutely fabulous project. And I'm really proud of what we've done in Boone. The pictures Damon showed of the South Fork out there, the partnership between the county and the town at Brookshire Park and the Bullock Farm and all that work. It's a mile of river that is no longer actively eroding. It has extreme benching and floodplain connectivity. We installed a few, if you haven't seen it yet on the Bullock site, we installed a few vernal pools in the bench down through there for some some habitat, wetland habitat. And then there's wetlands up on the Bullock floodplain that we're going to restore as part of that as well. And please know the town of Boone, of the 50-acre tract of land, we protected 30 some acres, all the bottom land that will be permanently reforested. We've already planted a few hundred trees down through there, and then certainly shrubs, thousands of shrubs. And we'll keep on doing that kind of work. But as you all know, you work and live and at the economic and population driver of Boone, North Carolina, that would be Appalachian State University.
Something we're not always proud of, or at least some of us anyway. But it is obviously an interesting give and take there between what some would call economic development and conservation of the many ecosystem services. Christine had a thought in the chat here about how to best make the case that biodiversity and ecosystem protection are valuable to the average citizen. What do you guys, are these things important to the average citizen, or is this just, are we really swimming in our own backyard pool?
I'll take a stab at that from a outreach perspective. You know, that's kind of the business that Mountain True is in, is advocacy, connecting the issues. We can consider ourselves a data-driven organization, so we invest a lot of resources in water quality monitoring and habitat improvement projects. And the positive intention of all that work, you know, aside from education outreach, and because we feel it's the right thing to do, but is to leverage that data and, you know, at times public outrage into, you know, meaningful lasting change through, you know, like, you know, statute change or legislation or funding, right? So I think that the average person does care about these issues, but generally only to the degree that you can make it relevant to them, right? So you can connect it. We've had some of our most success funding wise by connecting it with economic growth. You know, biodiversity is important because good water quality is crucial, or it's a building block, or it's a part of our natural resource driven economy in the high country, right? Folks come here because it's a wonderful, beautiful place to be. The biodiversity, the Southern Appalachians connected with, outdoor pursuits on the Blue Ridge Parkway, fly fishing, hiking, birding, those kind of things. So making those intersections highlighted in our work. But, I'd say it varies person to person, but making it, if it's, the ecological function that grabs them or the economic resource that's viable. But I think there's always a grabbing point for getting folks engaged. I'm not ready to give up yet.
I have a question for Damon and George, along these lines. How do you identify landowners who are willing to cooperate in terms of riparian conservation?
A lot of work. I mean, if you identify possibilities, it's just a direct outreach, sitting on the front porch and having a conversation and seeing what you can do to inspire and find common ground within the context and confines of Land and Water Fund's, requirements. I mean, there is the beauty, Damon, I don't want to steal your thunder, but I mean, I say a 50-foot buffer, but there is a sliding scale in there. I mean, they understand some of the constraints. I mean, if there's already an existing road and it touches within the 50-foot buffer, or say a greenway project is a perfect example where the greenways within that 50-foot buffer, but so and if you can gain 100 feet over here and kind of horse trade a little bit within that 50-foot buffer requirement, you can get creative, I guess, and help a landowner better envision what's possible without feeling like they're giving up too much.
Yeah, I mean, we a few years ago, Shay and Kristen Cockrell and John Wingu and I, we had a grant, Big Ideas grant. And what we tried to do was to systematically identify parcels of land where you get the biggest bang for your buck in terms of riparian conservation. And we could figure out the physical factors, we could identify the biological factors to identify those parcels. But the third component was identifying who would be willing to cooperate, right? And that's where things really fell apart. So we're looking.
I can almost guarantee you that whoever has the most needed restoration will be the most resistant landowner. I guarantee you that.
Yeah, we've supported and kind of paid for landowner outreach through our planning grants that, could go anywhere from sending postcards to thousands of people to pursuing leads. But in the end, it all comes down to the relationships that the local partners and organizations have with those landowners and word of mouth. And that's why one landowner seeing, they've got this restoration and they had to give up some of their land to protect it and keep the plants growing. But now the river's not eating their front yard alive and they're not losing their soil and it's not threatening the outbuilding or whatever, and really connecting it to their personal needs or really kind of fears of loss that streams and rivers can kind of put upon the riparian side landowners. But it's a long process, and every year we work with applicants that have projects that start out with only a small chance of potential, and then the landowner really gets on board and it happens, and others where they thought it was all going to work out and someone changes their mind or goes away or can't get it figured out. And so I think it's really about having the resources and the interest and the time to pursue a lot of leads and keep working with people year after year and keeping that pipeline going. It's about the connection year to year with those folks. Sometimes we've had projects that reapply 2 or 3 times or reconfigure 2 or 3 times and then are finally successful. But in almost every case, a great project that is successful, it generates more interest from around it. And so I've always kind of hoped that it's a little bit of the snowball collecting some more snow as it rolls, and it gets a little bit easier to do that work when you've got more good examples, especially in public areas. And the outreach and education programs and guided hikes and signage that our partners are doing is really critical. It's just slowly raising the awareness and the interest and the understanding of people that these various ecosystem services do actually have a positive impact on their backyard. And I think that's what it's about, is connecting it to their world, whatever it is. If it's the scope of where they mow their lawn, or where they hunt or fish or hike, I think that's really critical.
Yeah, well, we really appreciate your efforts in doing that. I know we couldn't find any systematic way to do that. So, you know, your work on the ground and with the people, I get is making all the difference. So,
Did you think about going through their mailbox?
You want to get together sometime, I'll tell you about a project I started that the landowner died on me. I had to keep on. We ended up with heirs and everybody else. Damon was part of that. He knows all about it. It's we work through whatever we can.
All right, folks. Well, this is interesting, and basically, as we indicated in our original announcement and things like that, the goal here is to kind of get the conversation started. And we'll be reviewing this here at SAEREC, and in RIEEE, we'll be thinking about some of the topics. And the next move, I think, might be another webinar or a small symposium or something like that, targeted more specifically to some of the topics that we brought up here, and how we might go about addressing them. So we're out of time now, so in terms of our hour, so I think we're going to formally wrap up. But if anyone wants to hang around and talk some more, or if George wants to regale us with this story he just hinted about, I'm willing to stay online for a little bit longer. But I think we're going to cut off the recording now. Thank you, Grace.